Alright, welcome to page 3, and what we're going to do now is we're going to, find the limit, but in this case we're going to see that when we substitute in, we're not going to get what we like. And so this is going to be kind of the basis of the squeeze theorem. And so the squeeze theorem is, what I'm going to do is I'm going to take, some function that is, say if g was the function that we had. And what we want to do, and we know that g is in between two other functions, say f and h. If I can find the limit of f and I can find the limit of h, and they both approach the same value, then I can say that the limit of g is also that same value. And that's why it's called the squeeze theorem, because we're taking two functions that, are less than and greater than, and we're finding the limits of those, and that's how we're going to be able to determine, okay, does our function that's in between those two other functions, does it actually have a limit? And if both of those approach the same, if the one above and the one below approaches the same value, then we can say that the limit exists at our function, in this case g. All right, so find the limit if it exists, or show that the limit does not exist. And so the first thing is we're going to substitute in. We're going to plug in, we get 0 times 0 over the square root of 0 squared plus 0 squared. And we find out we're going to get 0 over 0. So that tells us, okay, all right, the limit might not exist, but in order for me to find that, I need to, make sure that I cover all my pathways. And so, because the way that these notes are set up, I would prefer to show you how we could find it through the different pathways, but I'm going to show you that in the next two examples. So say, we tried to figure out if the limit exists or does not exist, and we couldn't prove that it doesn't exist. So that helps us determine, okay, maybe this limit does exist. And so what I'm going to do is I'm going to try to use the squeeze theorem. And so basically what we're going to do is we're going to take our function x, y over x squared plus y squared, but square root of that, and we're going to take the absolute values, so that way we can talk about approaching from the left and approaching from the right. Now, some things about this is that I can rewrite this to be the absolute value of x and times the absolute value of y all over the square root of x squared plus y squared. Now, I don't need to have the absolute value around that denominator, and the reason for that is because the square root of x squared plus y squared is always going to be positive. Because this is always going to be positive, I don't need to have absolute value around it, all right? Because that's always going to be positive. So now I'm left with this function with, an absolute value of x and the absolute value of y in the numerator, square root of x squared plus y squared in the denominator. Now, I'm going to try to find, two kind of like functions that are, one's going to be less than and greater than. So I take what I have and I realize, okay, well, one thing that I know about this right here is that this will always be positive. If I'm taking the absolute value of x and the absolute value of y, those are always positive, and the denominator is always positive. So that tells me that I'm going to have the lowest value that I can have is going to be 0. So if 0 is less than or equal to, because I know that, my function, now that I put absolute value, is always positive. And now I want to figure out, how far can I take this? And so I'm going to keep my function on the inside. So absolute value of x, absolute value of y, divided by the square root of x squared plus y squared. And now I need to determine, what's going to be, how far can I go to a function. And the thing is, I know that, the highest value would be the absolute value of x. And now the reason why it would be the absolute value of x is because the absolute value of y is going to be less than or equal to the square root of x squared plus y squared. All right. And so, how do we know that? Because if you know it, great, skip ahead a little bit. If you don't, it's because we have the absolute value of y here. And then if the smallest value is if we made x 0. If we made x 0, we would have the square root of y squared. All right, and the square root of y squared is just y. So y over y is going to be 1. That's the least we can be. X, if it's anything greater, if it's any other number other than 0, it could even be -1. All right. We're going to add that to whatever our y squared is. And so that's going to make our denominator bigger. It's therefore making, the absolute value of y over whatever's in the denominator smaller. So therefore, the highest value we can get is x. Now, one thing, we could have said it the other way. We could have said, instead of saying x, we could have said y. And we could have made that x. It didn't matter. We just had to make sure that we picked one. So, I'm going to stick with, what we have in the original just because if people skip through. So we know that, the biggest, this function, above this function is going to be the absolute value of x. The lowest is going to be 0. And so now all we have to do is go ahead and plug it in. So we're going to take the limit as x and y go to 0, 0 of 0, and that's just 0. Then we're going to do the same thing to the right, the limit of x and y as it approaches 0, 0, and we get the absolute value of x. And all we do is we now plug in 0 for x, and we're going to get 0. Because the limit is the same for both of these, the limit exists, and it exists at 0. All right. And that's the squeeze theorem. Now, the squeeze theorem is kind of like the last thing that you're going to do. The first thing that you're going to do, you're going to plug in. The second thing that you are going to do is really what's right here. And that is you're going to try to find pathways that leads to your function, but that you're hoping that either they're going to meet at the same point or they're not going to meet at the same point. And I guess you're kind of hoping that they don't meet at the same point, because if they don't meet at the same point, then your limit doesn't exist and you're finished. It's like, say if I had a point here, all right, and I'm coming this direction, so I have a pathway that's going to lead that way, and then I have another pathway that leads this way. All right, if they don't go to the same value, then your limit doesn't exist. So we're just trying to find some pathways. And so usually what you're going to do is you always want to take the path from the x-axis and the y-axis, just depending upon where your point is. So let's go ahead and do an example. So we want to find the limit if it exists, or show that the limit does not exist. So here we're going to plug in. If I plug in, I get 5 times 0 to the 4th cosine squared of 0 over 0 to the 4th plus 0 to the 4th, and I'm going to get 0 over 0. So now I want to check, okay, I want to see what are some pathways to 0, 0 for my function. And so the first pathway that I'm going to try, I'm going to go ahead and take my first approach, and that's going to be I'm going to approach 0, 0 along the x-axis. So that's the first pathway. I'm going to travel along the x-axis. So if I'm traveling along the x-axis, then I'm going to have f of x 0. Alright, and I'm going to go ahead and see if I can do the limit from that approach. So if I do that, I'm going to go ahead and use my function values, and I'm going to substitute in. And so as I travel along the x-axis, this is what my function's going to give me. So 5 times 0, the y value is still 0, cosine of 2x all over x to the 4th plus 0 to the 4th. And that's going to give me 0 over x to the 4th, which is just 0. So great, I got a value. It's 0. So as you know, I'm approaching 0, 0 from along the x-axis. My function value is going to give me 0. So now let's approach from 0, 0 along the y-axis. Alright? And so I'm going to have f of 0y. And now I'm going to plug it into the function. So 5y to the 4th cosine squared 0 over 0 to the 4th plus y to the 4th. 5y to the 4th times cosine squared 0 is just 5y to the 4th over y to the 4th, which is just going to give me 5. And because they approach two different limits, here we have 0 and here we have 5, because it approaches two different limits along two different lines, the limit does not exist. And that's how you solve it. Now you are going to have different pathways. In the next two examples, I'm going to show you different pathways, and then kind of how you always want to kind of choose your pathway.